Once again, greetings iCampSA students, and welcome to another video on the 2018 past paper, which is focused and on paper 2. So right now we're going to be doing question 4, which is still trigonometry. So yes, without wasting any time, let's go ahead and solve this question. Okay, so for 4.1 in the diagram below, ABCD, ABC, ACD, and ADE are right angled triangles. And remember what I told you, that once you know that you are dealing with the right angle triangles, you should remind yourself that you can use the Pythagoras theorem. The Pythagoras theorem, and also trig ratios, your SOHCAHTOA, and then you are given that BAE, BAE is 90 degrees. BAE, this angle is 90 degrees, and also BAC, where is BAC? BAC is 30 degrees, so it's this angle here is 30 degrees, that's your angle, and BC is 20 units, and AD is 60 units. AD is 60 units, and from there we also know that angle B there is also 90 degrees, angle C here is 90 degrees, and angle D is 90 degrees. From there we're asked to calculate the length of AC. So the trick with this question is to just simply isolate these triangles and solve them individually. So we're asked to calculate the length of AC. We can see that AC is the hypotenuse side of triangle ABC, of this right angled triangle ABC. And what do we have here? What do we know about triangle ABC? We know that angle A is 30 degrees and side BC is 20 units. So we have the angle of 30 degrees and the side BC, which is opposite to the angle of 30 degrees, and AC is the hypotenuse side. So we have the opposite and the hypotenuse side, which means we can use the sine trigonometric ratio, or we can relate the two using the sine trig ratio. Maybe before we get started, let's remind ourselves of SOHCAHTOA. When we are dealing with opposite and hypotenuse side, we use sine. When we are dealing with adjacent side and hypotenuse side, we use cosine, and when we are dealing with opposite and adjacent side, we use tangent or tan. And then AC here, we can see that AC is what? AC is the hypotenuse side. So let's go ahead and write sine 80 degrees. Sine 80 degrees is equal to, what's the side opposite to BC? The side opposite to angle theta is what? Is BC, opposite side, over the hypotenuse side, which is AC, and we are looking for AC. Let's make AC the subject. Therefore, we're going to have AC is equal to, what's the length of side BC? Is 20 units. We are given that. So we're going to have 20 units divided by sine 80 degrees. Therefore, AC is equal to, we know that sine 80 degrees, we can punch this in the calculator, or you can use the special angles, whichever way. Sine 80, 20 divided by sine 80 degrees, we get that AC is equal to 40 units. AC is equal to 40 units. And now let's look at triangle ACD. Once we know that AC is equal to 40 units, we can calculate CD by using the Pythagoras theorem. But at this point, we are not asked to calculate the side CD. Instead, we are asked to calculate the angle CAD, this angle here, that angle there. And we have two sides, we have 40 and 80. So side 40, which is AC, is adjacent, is next to that angle, and side AD, that's 60, is the hypotenuse. So we are dealing with a cosine trigonometric ratio, or we can use the cosine trigonometric ratio to find the angle CAD, since we are dealing with the adjacent and the hypotenuse side. And remember that we are focusing on this triangle. Now we are focusing on this triangle, so find size of CAD. Okay, so for 4.1.2, so we have determined that we are dealing with adjacent side 4.1.2 and the hypotenuse side. Therefore, we're gonna use the cosine to calculate the angle. Cos CAD is equal to the adjacent side. What is the adjacent side? Is AC. Is AC over the hypotenuse side, which is AD, and we know that AC is 40 units. This is 40, so cos of angle CAD is equal to 40 over AD. The hypotenuse side is 60 units. Therefore, let's make CAD the subject. Therefore, we're gonna have cos inverse 40 over 60 is 2 over 3. Let's just put 40 over 60 as it is. Therefore, CAD, let's quickly punch that in our calculator. Cos inverse 40 over 60 is equal to 48.19 degrees. That's the angle CAD to 2 decimal places. Let me see if they specified. Okay, that is angle CAD. And then next we are asked to calculate the length DE. This length here, the length DE. And what do we know about length DE? If we were to focus on the triangle ADE, this triangle here ADE, we know that 60 is there. We have side 60, and then what else? We have just calculated the angle here, which is 48.19, and then we know that all of these angles here at A are equal to what? Are equal to 90 degrees. So all of these angles from here to here, they are equal to what? 90 degrees. Therefore, we can calculate the size of this angle here. The size of this angle, we're going to call it angle DAE. We can calculate it because we know that the sum of all those angles is equal to 90 degrees, as it is represented by that 90 there. And also, I think we were told that yes, BAE is equal to 90 degrees. So let's go ahead and calculate the size of the angle DAE. Angle DAE, this is 4.1.3. 4.1.3. Angle DAE is equal to the angle 90 degrees minus 48.1 degrees minus the 80 degrees angle that we were given. Therefore, angle DAE is equal to 90 minus 48.19 minus 80 degrees. is equal to 11.81 degrees. 11.81 degrees. Okay, and then once we are here, and remember that we are looking for side DE, we are looking for this side, and this side is opposite to this angle that we have just calculated. 11.81 degrees is opposite to that side, and then we have the adjacent side, which is 60 degrees. Therefore, since we are dealing with the opposite and the adjacent, we can use the tangent. So we can use the tangent. So therefore, the tan of angle DAE, tan of angle DAE is equal to the opposite over the adjacent. The opposite is what? Is DE over AD. DE over AD. DE over AD. And we are looking for DE, so let's make it the subject. DE is equal to AD cross multiplication. What is AD? I think it's 60. Yes, it's 60 we were given. It's 60 times tan of why did I write 18.81 here? This is supposed to be 11.81. Tan of 11.81 degrees, and this is DE. Why do I make mistakes now? Therefore, DE is equal to 60 tan of 11.81, which gives us 12.55 units. 12.55 units. That's the size of DE. That's the size of DE. Okay. And then next, we'll also solve for x, okay, in the following conditions. Copy. I'll quickly just paste this here so that we can see what we are referring to. It's okay. Let's drop. Yeah. So for 4.2, we are now solving for x, bringing in algebra from into trigonometry. Let's solve for x correct to 1 decimal place. So, and we already know that once they tell us that's correct to some decimal place, we know that we're gonna be using a calculator to solve for this, or at least for the most part. And we are told that x is between 0 and 90 degrees. Okay, let's go ahead and calculate and solve for x. Okay, 10x is equal to 2.01. Let's make x the subject. X is equal to tan inverse 2.01. We punch that in the calculator. If you don't know how to do this, you're just gonna say second function 10, then you're gonna get the 10 inverse if you are using the Casio. If you are using the sharp calculator, I think you're gonna say second function tan, and then it's gonna give you the 10 inverse. If you are using the Casio, you're gonna say shift plus tan is gonna give you the inverse, the inverse, and then the answer is 63.5 degrees, correct to 1 decimal place. And then let's go ahead to 4.2.2. we have 5 cos x plus 2 is equal to 4. Let's start by taking 2 to the other side. We're gonna be left with 5 cos x is equal to 4 minus 2, which is gonna be 2, and then the next step is to divide by 5 on both sides. So we're gonna have cos x is equal to 4 minus 2 is 2 over 5, and then once again let's isolate x. X is equal to cos inverse of 2 over 5. Therefore, x is equal to cos inverse of 2 over 5. X is equal to 66.4 degrees. 66.4 degrees. That is our x, 66.4 degrees. Okay, and then next, let's do 4.2.3. We have cosec x, and we know that cosec x is what? Is the reciprocal of sine. Is the reciprocal of sine. Okay, so for 4.2.3, 4.2.3 of cosec x, cosec x over 2 is equal to 3. Is equal to 3. Okay, we'll also solve for x. First thing first, let's remove the 2 in the denominator by applying the cross multiplication. We will be left with cosec x is equal to 6, and then we know that cosec x is equal to us, or is the reciprocal of sin x, so we can just say 1 over sin x is equal to 6, and then let's make sin x the subject by using the cross multiplication. We're gonna have sin x is equal to 1 over 6, and then therefore x is equal to sin inverse 1 over 6. Sin inverse 1 over 6. Therefore x is equal to sin inverse of 1 over 6. X is equal to 9.6 degrees. X is equal to 9.6 degrees. And there you have it. There you have it. Your x. I think, yeah, this is the last question for question 4. Thank you for watching this video. If you have stayed up until this point, I will see you on the next lesson, and I wish you good luck with your examination. Don't forget to follow us on all the social media platforms and subscribe to our YouTube channel. Thank you.